We live on a planet of remarkable natural beauty, but it's the paradox of our atmosphere that its most beautiful and remarkable creations, the great storms, are also incredibly destructive. And it's our great challenge to coexist with these storms. And I'm going to talk with you today a little bit about the great storms of the future, the next 30 years, and some of the challenges our interconnected society will face from extreme weather events, and maybe some of the things we can do in order to reduce our vulnerability to these great storms. Little background on me. I write a blog for weatherunderground.com. During hurricane season, I talk a lot about hurricanes. Other times of year, I talk about whatever weather events are interesting and about climate change as well. I've been a meteorologist for about 30 years, spent about 13 years in college studying weather. And for 4 years, I flew with the hurricane hunters out of Miami, Florida. I went into a number of pretty impressive storms. It was the ideal job for the true student of extreme weather. And not only did I fly into hurricanes, but in the winter, I'd go fly in the Arctic into winter storms. So you found me in Alaska in the winter, or Maine, or Norway. And in the summer, I flew through a lot of hurricanes. This is a storm many of you who were here in 1987 will recognize, Hurricane Emily. I flew through that when it was a Category 3 hurricane off the Dominican Republic. We hit 3 Gs in the eye wall of Hurricane Emily, had a flutter in our wings that nearly tore them off, but here I am to talk about it. In 1988, I flew through the strongest hurricane of all time, Hurricane Gilbert, off of Jamaica. And my final flight with the hurricane hunters, which was almost final in a more permanent sense, was into Hurricane Hugo. And the reporter we carried on board wrote this rather shocking story about the flight, which really wasn't far off the mark. We went through the eye wall of the hurricane, which is that pink part you see there. And while we were in the eye wall of this Category 5 storm, we hit 5.5 Gs of acceleration. The wings are only rated to 6 Gs. We had an engine catch on fire. The plane went out of control. And fortunately, we were right near the calm eye. We popped into the eye. The pilot pulled us out 800 feet above the water. And we had some time to clean up the inside, which looked like this after the flight. And there's the shot of the eye of Hurricane Hugo. I wrote all about it on my website. You can go check it out. There's a full story with pictures. Now on to the future. Well, before we look at the future, let's look at the past. In the past 30 years, we've had 12 $10 billion weather disasters in the US, only one $100 billion weather disaster. And in fact, that's the world's only $100 billion weather disaster in history, Hurricane Katrina, number 1 on that list. Note that the list of most expensive disasters has a lot of hurricanes, more than half of them, but also look at number 2 and 3 there, droughts. Droughts can be incredibly destructive. The 1988 drought in the US, $71 billion in damage. So let's think about what climate change might do to some of these disasters, in particular to hurricanes. If you're going to heat up the oceans, you're going to provide more energy for a hurricane. You can get the winds stronger, you can increase the rainfall, and also with climate change, you raise sea level due to melting of the ice, so the storm surge which goes ahead of the hurricane can cause much more damage. We really don't know what climate change is going to do to hurricanes, but it makes sense that it'll probably make the strongest ones stronger because they've got more energy. Here's one model result which shows by 2100 we expect in the red colors there 2 to 3 more Category 4 and 5 hurricanes, the strongest ones capable of causing the most damage near Florida and the Bahamas. Bermuda, this model says maybe 1 or 2 more of these per decade by the end of the century. So now let's go look at what the future might hold for not only intense hurricanes, but all weather-related disasters, the ones most dangerous to society, the ones that can cause $100 billion of damage, which is about 1% of the quarterly GDP of the US, capable of causing a recession. So I'm giving probabilities on all these slides here. I'm going to count down from 9 to 1, and those probabilities are 30-year probabilities. If you have a 1% chance in a given year of having a particular sort of weather disaster, if you do the math over a period of 30 years, there's about a 26% chance that this 1 in 100 chance will come to fruition in that time. So I'm rating, based on past history and adjusting a little bit for climate change, what the odds of these $100 billion disasters are. And for a Galveston-Houston hurricane, I think about a 30% chance that we'll see a $100 billion hurricane, category 4 or 5, hitting that metropolis. New Orleans, a little bit higher chance. I don't think they quite need as strong a hurricane because they've got that extensive levee system. The sea only has to breach it in one place to flood a city that's up to 20 feet below sea level. The potential is very high that we'll see another Katrina that will flood New Orleans. Miami, even higher chance. I'm giving it 50% chance. In 1926, they had a Category 4 hurricane. Were it to hit the city today, would cause $100 million in damage quite easily. Now, all three of these disasters would be a blow. I mean, $100 billion is a lot of damage to do, but it's probably not going to crash the economy. Now let's look at some disasters that potentially could really cause serious problems not only to the US economy, but to the world. New York City. We had a storm this year, Irene, which hit New York City directly, but fortunately it was only a tropical storm when it hit. But it gives us a little pause to think about what could have happened. New York City is very vulnerable to a strong hurricane. It doesn't even have to be that strong because there's not much protection. Note the financial district of New York City, and note how high the seawall is protecting it. Only 5 feet at mean sea level. At high tide, it's only 3 feet. The sea will come into the financial district and flood it if you have a Category 1 or stronger hurricane hitting New York City. Here's a plot showing the expected height of a storm surge in New York City for a Category 2 hurricane. Those red colors are 20 feet. There was an 1821 hurricane that hit New York City directly that brought a 20-foot storm surge to Manhattan. Were this hurricane to hit again today, it would flood all of lower Manhattan, the financial district. It would flood both airports, move up the Hudson River, inundate the power plants which supply all of New York City with power, knock them offline for a period of weeks, potentially months. New York City has 10% of the entire GDP for the US. If you knock New York City offline for a period of weeks or months, you're going to knock the American economy down big time, and potentially the world economy as well, because of all the financial activity in New York City. New York City has had some winter storms in the past that have caused major damage. LaGuardia Airport's been flooded by a storm surge. The New York subway system in 1992 got flooded by a storm surge that crashed the entire mass transit system of the city for 10 days. Cost $250 million. Seawater in subways is not a good thing. Let's think about Hurricane Irene. This was a forecast made 3 days before Hurricane Irene hit New York City of what the hurricane was going to do. This was from our best performing model that we have. It was forecasting a Category 4 hurricane basically on New York City's doorstep off the coast of Delaware, and this would have been a catastrophe had it actually been correct. Fortunately, it wasn't. But there will be a day, has happened before, will happen again, a New York City hurricane is an inevitability. The city will flood with a 20-foot storm surge. Note that in the future, you can see with reference to a person's height there, we expect a lot of sea level rise due to global warming, increasing the level of the oceans, somewhere between probably 2 and 6 feet by the end of the century. Now that 5-foot wall protecting Manhattan doesn't seem so good, does it? It's not going to do the trick. So what do? Well, there have been a number of cities along the New England coast that have built storm surge barriers because of past bad experiences with hurricanes. Providence, Rhode Island is one. They built a 7-meter high storm surge barrier that has been keeping out all the storm surges that have affected that city since the 1950s. New York City could do the same. For a cost of $5 to $10 billion, we could build a Netherlands-style storm surge barrier across some of the choke points that the storm surge would come into the city. And I think this is something New York City is going to have to do, particularly with sea level rise coming this century. Let's move on. Let's think about drought. Now, in 1988, if you recall from an earlier slide, we had a $71 billion drought in the US. If that drought were to recur now, well, it would be much worse. The climate has warmed since 1988. When you have a warmer climate, your droughts get more intense. They cause more drying and you have more damage to crops. And if you've got a major drought like the 1988 drought hitting again, well, we were lucky it didn't happen this year because food prices are at record highs due to the Russian drought of last year. If we get back-to-back droughts in major grain-producing areas in the world, we're going to be in serious trouble. There is already this year food riots and uprisings in the Middle East and so on because we had that Russian drought. If we get another US 1988 style drought, it could really cause major world problems because of the scarcity of food right now. Let's keep on going. Let's think about floods now. California is very vulnerable to huge floods. They had a big storm back in 1862, 20 inches of rain in a period of a month over the Central Valley, flooded 20% of the area of California. Were this type of storm to recur again, the thought is it would be a $500 billion disaster, which would have ripple effects not only in the US, but probably in the world economy. Now we're getting to the top three. Now things get really scary. The rest was, no big deal. But let's think about the Mississippi River. About 300 miles upriver from New Orleans, you have the most important structure in the entire world. It's a structure called the Old River Control Structure. It's a series of 3 dams that separates the Mississippi River from another river called the Atchafalaya River. Back in the late 1800s, this Atchafalaya River was not connected to the Mississippi, but it connected up and started siphoning away some of the Mississippi's flow. As the decades went on, it started taking more and more of the Mississippi until by the 1950s, it was taking 30% of the flow of the Mississippi. Now, when that water goes down the Atchafalaya, it's going down a track 3 times as steep and half as far to the Gulf of Mexico. The Mississippi really, really, really wants to go that way. And the only thing keeping it from going that way is this structure here. Many times in the past, the Mississippi has changed course. About every few thousand years it does that. Here's some of the old meanders of the Mississippi. And this is kind of the Army Corps of Engineers version of what the Mississippi should do. So there's a fundamental conflict here. The Mississippi really wants to do something, and the Army Corps doesn't want to let it. Guess who's going to win eventually? The river's going to win. Now, the Army Corps has built this structure here, and they say that it would need a 1 in 750-year flood to overcome it. That's about a 4% chance over a period of 30 years. I don't believe those numbers. This year, we had a 1 in 300-year flood at the Old River Control Structure. The Army Corps was really surprised by this. But they shouldn't be, because the history that they're using to come up with those numbers is invalid. We're in a new climate now. It's a warmer climate. There's more moisture in the atmosphere, more moisture for heavy rainstorms. And also, we've engineered the floodplain of the river to not give it as much room to spread out. So now we're putting more water behind the levees, and we're raising the flood heights. Let's think about what would happen if the Old River Control Structure failed and the Mississippi changed course to where it wants to go. Well, obviously it would be bad for the communities downriver, and it would be very bad for New Orleans, who would lose its freshwater drinking supply. Also, you would lose fresh water for a ton of businesses, the petrochemical industry, some oil refineries, about 14% of U.S. oil refining capacity, natural gas refineries, they all need fresh water. If the Mississippi changes course, it's going to be devastating for them. It'll be a slow motion kind of disaster, but a disaster nonetheless. It would probably cost trillions of dollars. But the biggie now is, if you look up there, 60% of all U.S. grain is exported down the Mississippi River on barges. If you lose the barge traffic going down the Mississippi, you're going to shut down the American economy. It costs $300 million per day if you shut down the Mississippi, which has happened a few times for accidents, and Hurricane Katrina did it for a little while. Imagine 300 million, you start multiplying by months here. It would take months, perhaps years, before they would figure out how to dredge a route to get the barges back down through the Mississippi to the Gulf. And during that time, what happens? Well, all the grain in the U.S. piles up. Not only does it affect the U.S. economy, think about world food prices now. The U.S. is the #1 exporter of grain to the world, and there's going to be massive food riots, political unrest. It's going to have a huge cascade impact if the Old River Control Structure fails. That's why I call it the most important engineering structure in the world. We can't let it fail, but it will if we keep on our current path. So what we need to do to reduce the odds of that happening, we need to give room for the river. This is something they do in the Netherlands, who are the world's experts at flood control. They have a program called Room for the River. You don't develop your floodplains. You buy out people that are in the floodplains. You allow the river to go into the floodplains a little more. You move the levees further away so that you don't constrict the flow of the river into such a narrow space. You really got to make some common sense sorts of behavior changes now of how we manage our floodplains in the future, because we have some really critical things to protect in our floodplains. Okay, now we're getting to the one that makes me most nervous, is a cataclysmic geomagnetic storm. This isn't weather in the conventional sense, we call it space weather. But what happens is when the sun undergoes a big explosion of sunspots, it blows out a piece of its atmosphere towards the Earth. Those high-energy particles go into the Earth's magnetosphere, get funneled down to the poles, and they induce, well, beautiful displays of auroras. But more seriously, they also induce electrical currents in the ground that flow into our electrical power grid. Our electrical power grid is AC power. The geomagnetic storm current is DC power. The two aren't very happy with each other, and you can burn out these giant transformers that are required at our major power plants to keep them running. There was a storm in 1989 that burned out this huge transformer at a power plant in New Jersey, and we're theorizing that should we have a 1 in 100-year geomagnetic storm, it could crash the entire electrical power grid across huge sections of the northeast US and the northwest. And guess what? Those transformers that it's going to burn out, they take months or years to replace. So we're looking at months or years where huge sections of the country could have no electrical power. Again, a multi-trillion-dollar disaster with global impacts. I don't want to see this one happen. Odds of it happening, 30% in the next 30 years. There have been 2 such storms that have happened since 1850 that would probably cause a mass collapse of the electrical power grid. Finally, I don't think this one's going to happen, at least I pray it doesn't, but if you launch a lot of nuclear weapons, about 100 or so, you could cause a cooling of the atmosphere, what we call nuclear winter. You reduce the amount of sunlight coming in, the temperatures at the surface go way down. Here's a plot of temperature over the last 1,000 years showing the year without a summer in 1816 when a massive volcanic eruption caused kind of a winter-like scenario. You would cause crop failures, mass starvation probably because of not enough food being grown. And you can see that red line there goes actually colder than the year without a summer in 1816. Were, say, limited nuclear war in Pakistan and India to happen with 100 or so weapons. So we got to keep working towards peace. That's critical. We can't let that happen. And after all that death and destruction, I want to encourage you, if you see something beautiful in the atmosphere, upload your weather photos to us. We take 600 weather photos from you guys a year, and I thank you for your attention.